Welcome back. Today we're going to talk about volume of three-dimensional objects, and a couple of things that we need to talk about with volume is we're going to start out laying the groundwork. And so when I have this pentagonal prism here, it's given in two views. This is an oblique pentagonal prism because it's got that little bit of tilt to it, and this is a right pentagonal prism. And a couple of things that we need to know about these. We need to know the area of the volume, or the formula for the volume of a prism. It's equal to the area of base times height. And so when I have this oblique prism here, this is going to be the height. Drop directly down from the height, how tall it is, down to the ground at a 90-degree angle. The height of this one is going to be just that side length because it intersects the ground at a right angle. Volume of a cylinder is area of base times the height as well. And that's okay because with the area of the base times the height, it's basically, if you think about it, as a bunch of little shapes stacked on top of one another. It's that how big that shape is times the amount of times we would do it, and that's how tall it is. Okay, and so that's it. That's all there is to it. And so when we find the volume of these shapes here, really what we're going to do is find the area of the base and multiply it times the height. So when I look at this first one, and this big B is going to be area of base, you'll see that it doesn't really matter. So if I make this the base, that's going to be 10 times 12 base times the height, which is equal to 12 times 10 times 8, which is going to give me 120 times 8 is equal to 960 centimeters cubed, and volume is going to be in cubed units. Okay? What if I made this front side the base? Then it would be 8 times 10 times 12, which would also give me 960 centimeters cubed. So I hope you see it doesn't really particularly matter which one it is, and for this rectangular prism, it's going to be length times width times height. And so that's the basics of finding the volume of a prism. So let's move over to this one. Base times height. Area of the base. Well, the base in this case is a pentagon, and at this point we should be pretty comfortable with the pentagon as a polygon. And I know this is 36. They were nice to us and gave us that one this time. And this whole thing is 5. So this is going to be 2.5. I'm going to pull out this shape here. And this is going to be 36. This will be 2.5. And I know I need the apothem because this is going to be 1/2 apothem times perimeter. And my apothem is going to be involving these trig ratios once again. So tangent 36 is equal to opposite over adjacent, or apothem, multiply times A on both sides. A tangent 36 is equal to 2.5 divided by tangent 36 divided by tangent 36. A is equal to 2.5 divided by tangent 36. Now, let me move this up just a little bit. That's my apothem. And so coming over here in green, let me box this off. The base is equal to 1/2 2.5 over tangent 36 times the perimeter, which is going to be 35, right? Because it's 5 on each side. Oh, no, just 25. I messed up. I was thinking of this 7 over here. Just going to be 25. Okay, and so what I end up with is, I've got it written down here, 31.25 over tangent 36. That's the area of my base. And so the area of the base times the height is equal to 31.25 over tangent 36 times 7, which is going to give me a grand total of about 301.1 meters squared. That's all there is to it. Area of the base. Base being something we already know how to find the area of, times the height. Same for the cylinder. Base times height. Well, the base is equal to pi times radius squared equals pi times 8 squared, 64 pi. And then 64 pi times the height, 64 pi times 12, 64 times 12, 768 pi meters cubed. This one should also be meters cubed, and that's all there is to it. Area of the base times the height. That's all there is, guys. Thanks for watching, and we will see you next time.